Hello, we've got a GCSE Chemistry question on atomic structure. It's taken from the AQA specification, higher tier. Okay, so we're told that this question is about the halogens. That's group 7 of the periodic table, and we are told that a fluorine atom can be represented as 19,9F. So let's think about the numbers. 19 is the mass number of this particular atom, which means that there are 19 protons and neutrons in each atom. 9 is the proton number, or sometimes known as the atomic number, and that means that there are 9 protons in the nucleus of the atom. We are asked for the total number of electrons in a fluorine molecule. So first of all, if there are 9 protons in the nucleus, protons are positive and atoms are neutral. The only subatomic particle which is negative is the electron. So if there are 9 protons in the nucleus, there must be 9 electrons orbiting the nucleus to make the atom neutral overall. But we're not asked for the number of electrons in an atom, we're asked for the number of electrons in a molecule. There are 2 atoms of fluorine in each molecule, so 9 electrons per atom, but there must be a total of 18 electrons per molecule. We can go a little bit further with this question to help our revision, and we can think about the total number of electrons in a fluorine atom, the total number of protons in a fluorine molecule, total number of protons in a fluorine atom, total number of neutrons in a fluorine molecule, and the total number of neutrons in a fluorine atom. So you can get a little bit more out of this question by having a go at some variations there. So if you want to pause the video at this stage and have a go. Okay, welcome back. So we said before there are 9 protons in the nucleus and they must be cancelled out by 9 electrons to make each atom neutral overall. So there must be 9 electrons per atom. What about the protons in a molecule of fluorine? Well, there are 9 protons in each atom. There are 2 atoms per molecule, so that makes 18 protons in a fluorine molecule. Number of protons in a fluorine atom, simply given by the number 9 there, the atomic number or the proton number. Number of neutrons in a fluorine molecule. So this one's a little bit more difficult. 19 protons and neutrons in total per atom. That's the mass number, the 19. So we know how many neutrons there are because we can just simply take away the 9 protons from the 19 protons and neutrons, leaving us with 10 neutrons in each atom, 2 atoms, so 20 neutrons per molecule. And then finally, the total number of neutrons, well, 19 protons and neutrons in each atom, 9 protons, 19 take away 9, leaves us with 10. Okay, so next we have a question about reactivity, and we are asked to explain why chlorine is more reactive than bromine in this displacement reaction. We have to be aware that when chlorine atoms react, they gain electrons to become chloride ions in this scenario. So why is chlorine more likely to become a chloride ion than bromine to become a bromide ion? Let's take a look at the atomic structure. We know that both chlorine and bromine have got a positive nucleus of protons and neutrons. We also know that they both have electrons that exist in shells orbiting the nucleus, and that reactions involve the outermost electron, so both of them have got 7 outer shell electrons. So what's different is the number of electron shells. When chlorine reacts, it accepts an extra electron. When bromine reacts, it accepts an extra electron. So shown the extra electron there as a circle rather than across the electrons which they already had. When they accept those electrons, they become ions. So chlorine goes to chloride and bromine goes to bromide, and we show that they are ions using square brackets. Because they've got an extra electron, they now have an additional negative charge. So looking at the electron structure, why is it more likely for chlorine to gain an additional outer shell electron? So that's what the question is really about. Okay, so let's get to the addressing the question now. We have seen in the previous diagram that when chlorine and bromine react, they gain an electron. So why would chlorine gain an electron more readily or more easily than bromine? Chlorine atoms have less electron shells than bromine atoms. Chlorine atoms have less shielding between the nucleus and an incoming electron. There is more attraction between the nucleus and an incoming electron in chlorine atoms. Okay, so new content is added regularly. If you've got any questions or suggestions, please just get in contact. Thanks for watching. We took these questions from AQA GCSE Trilogy Science Chemistry. It was paper 1 higher tier 2018 and they were questions 4.3 and 4.5. The format that we used was black text for the question, blue text is the answer, and red was just additional information and explanation. Once again, thanks for watching.